What's up, guys? So if you were absent today, or you're just kind of going back and reviewing the notes for today, I'm not going over the factoring task. So that's for you guys to kind of complete. Most of that stuff you should be able to do, and then if there's something that you got stuck on, maybe going through a couple of these problems that I'm about to go through might help you with that. So first and foremost, factor by grouping is nice because it will work. It will work all the time unless something can't be factored, obviously. So it's a nice method. It's a little lengthy, I admit. But anyways, and there's other ways to factor. I'm going to actually put some videos on Moodle about some of those ways that I'm not really going to go over in class, just for the sake of time. So if you're interested in something like that, then be on the lookout, and I'll put those on there. Okay, so let's look at, these aren't the examples from the factoring test, but let's see if we can factor this by grouping. So the first thing, step one we want to do is we want to identify before we do that, I almost skipped this. We want to see if there's a greatest common factor, GCF, between all three of these terms. And let's look at the number 2, 12, and 10. The first thing I notice is that those are even. So that means that they can all be divided by 2. So I'm going to factor out a 2. And when I factor out a 2, I create my parentheses, and then 2 times something has to give me 2x squared. I already have the 2 taken care of, but I need the x squared. And then 2 times a negative 6 will give me, a negative 6x, will give me that negative 12x. And then 2 times 5 will give me 10. So factoring is just kind of thinking about distribution in reverse. I'm doing that thing. Okay, so from here, my A value is actually, I'm looking at just this. So the number that I factored out in the front, all that's going to be carried down for the right. So all I'm looking at right now is what's inside of here. So my A value is the coefficient in front of the x squared, which is 1. My B value is the coefficient in front of the x term, which is a negative 6. And my C value is the constant term at the end. So step one, or I don't know what step this is. The first thing I want to do, second step maybe, is I want to multiply A times C. So I'm just going to write this as A times C. Well, in this example, our A value is 1 and our C value is 5. So 1 times 5 equals 5. Then I want to make a factor tree using the number 5. The good thing about that with 5 is prime. So if I'm trying to list, I don't want to do that. If I'm trying to list the factors of 5, that would just be 1 times 5 and negative 1 times negative 5. Then I want to look at my B term. So my B term, B equals, what do we say B equals? Negative 6. So I want to add these together now and see if one of these equals negative 6. So that equals positive 6 and that equals negative 6. These equal negative 6. So from here, I'm going to go back through and I'm going to rewrite my middle term using those 2 numbers that I just circled as coefficients for that middle term. So I'm going to start by writing the 2, which is what I factored out in the beginning. Everything else is going to stay the same except the middle term. I'm going to replace that with minus x minus 5x. Those are the coefficients for the middle term that I circled. If I added these together, I get this. Okay, I'm just kind of splitting that, expanding that using those 2 numbers. And then I have the plus 5 at the end. Okay, so from here, we are going to group, and it's going to look weird because we're going to group inside of something that's already grouped. So we're going to have this going on, and then we're going to group I'm going to keep these blue parentheses. So I'm going to put the x squared minus x in its own set of parentheses, and then the negative 5x plus 5 in its own set of parentheses, like this. This is not the factors. I know it looks like factors. We have 2 binomials being multiplied together. Here is where you factor out the GCF of each one of those. So this 2 gets carried down. We're done with that, but it's still part of our problem. Now we're looking at this factor. The first group we did. We want to factor out the GCF of that group. Let me keep this first parentheses in blue. So I'm going to factor out the GCF. the first term has an x squared, the second term has an x, so they share at least one x. So I'm going to factor out a GCF of an x, and then I'm going to create my parentheses. What goes inside of here has to multiply to give me that. So x times x will give me the x squared, and x times -1 will give me negative x. That's done. I'm done with that. The x squared minus x is factors as x times x minus 1. Next thing, I want to look at the this, negative 5x plus 5. You always want to make sure whatever that number is on that second one, if that's positive, you factor out a plus sign. If it's negative, you factor out a minus sign. Since this is minus, I'm going to factor out a minus sign. And I'm looking at the GCF between negative 5x and 5. Well, look at the numbers themselves. They both have a 5. That's like written there for you. And the other term doesn't have an x, so you don't have an x in common. So you'd factor out a 5 and then figure out what goes inside of there. Negative 5 times what is going to give me negative 5x. Well, negative 5 times x will give you negative 5x. So you're essentially just dividing by that, dividing each one of those terms by that. And the negative 5 times a negative 1 will give me positive 5. Then we get here. Now, the reason yesterday when we factored out the GCF, I specifically gave you problems that looked like this. That looks like this. And I did that because we're going to get to this point in factor by grouping where you have two binomials that are the same. And the way we do that is we look at each one of these factors and we see that the x minus 1 is the same. So I'm going to bring this 2 down. Don't freak out. We'll bring this 2 down. And I'm going to end up factoring out this x minus 1. So I'm going to factor out this x minus 1 and put that up here, because they have that in common. And then I'm going to create these parentheses. X minus 1 times something needs to give me this. Well, they already have the x minus 1. What I need is the x. And then x minus 1 times something else has to give me negative 5 times x minus 1. Well, that would just be minus 5. The easiest way to kind of, and this is our factors, by the way. The easiest way to kind of think about this is that what you see that happens twice, like the x minus 1, write that once, and what's on the outside of the parentheses, put that in parentheses, like the x minus 5. Let's try this one. Okay, so there's no GCF here. So I'm just going to start by multiplying, I'm going to identify A, B, and C. A equals 4, B equals negative 3, and C equals negative 1. So if I multiply A times C, I get A times C, which is 4 times negative 1, which equals negative 4. Step 2, I want to make a factor tree of negative 4. And then I want to add these together. So we got to pay attention to this sign. So the signs in our factor tree are going to be different because they have to multiply to a negative number. I always start with 1. 1 times what is negative 4? That would be negative 4. Then I have negative 1 times positive 4. So I always do find 1, and then if it's negative, make the opposite number negative, and so on and so forth. We also have 2 and negative 2. I don't need to make that opposite because if I did this, that's just the same thing. Okay. So those are the only factors. Let's go ahead and add these together. So that would add together to negative 3, this would add together to positive 3, and this would add together to 0. So what I'm looking for is my b value, b, which is negative 3. Which one of those add to negative 3? That would be these. So now I'm going to replace that middle term with 1x. It does not matter what order you write these in, by the way. I could have put the negative 4x first. We're going to get the same thing, just in a different order. Okay, here's where I'm at. I've got 4 terms. Now I start grouping. Put parentheses around the first 2 terms, and now we're going to factor out the GCF. So 4x squared plus x, I'm looking at the 4 and the 1. They have nothing in common other than a 1. The x's, on the other hand, you have 2 x's here and 1 x here, so they share at least one of those. So I'm going to factor out an x. And then I'm going to figure out if I divide or factor out an x out of 4x squared, x times 4x will give me that 4x squared that I need up here. And then I'm going to do the same thing. X times what gives me x? Anything times 1 will give you itself. Here's that. Remember, you got to factor out that sign here with it, so that's going to be a minus sign. Here we have 4 and 1 share nothing in common other than 1, and the other, in terms of the variable x, the negative 1 does not have an x with it. So this is the only time you really consider factoring out a 1. So we are going to factor out a negative 1 because that's what they have in common. And then we can write our parentheses. Negative 1 times what is going to give me negative 4x. Negative 1 times 4x will give you negative 4x. And then negative 1 times a positive 1 will give me a negative 1. So you got to pay attention to those signs. Now we're back where we started at that last one. What's on the outside that I have in green? Put that in parentheses, x minus 1. And what's in the blue here is our other factor, what happens twice. This is our answer. If we redistributed that, we'll get where we started. If we do this, and we have 4x times x gives us 4x squared, and then 4x times that gives me negative 4x. Then we move to the inside, 1 times x gives me x, and then 1 times negative 1 gives me negative 1. We add our like terms in the middle, and we get 4x squared minus 3x minus 1, which is exactly what the problem is to begin with. Okay, that is factor by grouping. We're going to talk about a different method tomorrow. So come back, stay tuned, and we'll see you then.